Service often needs to publish messages as part of a transaction that updates the database. Both the database update and the sending of the message must happen within a transaction. Otherwise, a service might update the database and then crash, for example, before sending the message. If the service doesn't perform these two operations atomically, a failure could leave the system in an inconsistent state. One solution that fits well with modern applications is using a database table as a message queue. Let's imagine that your application is using a relational database. A straightforward way to reliably publish messages is to apply the Transactional Outbox pattern. This pattern uses a database table as a temporary message queue. Service that sends messages has an Outbox database table. As part of the database transaction that creates, updates, and deletes business objects, the service sends messages by inserting them into the Outbox table. Atomicity is guaranteed because this is a local aside transaction. The Outbox table acts as a temporary message queue. The message relay is a component that reads the Outbox table and publishes the messages to a message broker. You can use a similar approach with some NoSQL databases too. Each business entity stored as a record in the database has an attribute that is a list of messages that need to be published. When a service updates an entity in the database, it appends a message to that list. This is atomic because it is done with a single database operation. The challenge, though, is efficiently finding those business entities that have events and publishing them. There are a couple of different ways to move messages from the database to the message broker. We will look at each one of them. Publishing events by using the polling publisher pattern, and publishing events by applying the transaction log tailing pattern. If the application uses a relational database, a very simple way to publish the messages inserted into the Outbox table is for the message relay to poll the table for unpublished messages. It periodically queries the table. Next, the message relay publishes those messages to the message broker, sending one to its destination message channel. Finally, it deletes those messages from the Outbox table. Polling the database is a simple approach that works reasonably well at low scale. The downside is that frequently polling the database can be expensive. Also, whether you can use this approach with a NoSQL database depends on its querying capabilities. That's because rather than querying an Outbox table, the application must query the business entities, and that may or may not be possible to do efficiently. Because of these drawbacks and limitations, it is often better and in some cases necessary to use the more sophisticated and performant approach of tailing the database transaction log. The sophisticated solution for the message relay is to tail the database transaction log, also called the commit log. In fact, every committed update made by an application is represented as an entry in the database's transaction log. The transaction log miner reads the transaction log entries. It converts each relevant log entry corresponding to an inserted message into a message and publishes that message to the message broker. This approach can be used to publish messages written to an Outbox table in a relational database management system or messages appended to records in a NoSQL database. There are a few examples of open source projects using this approach. For instance, Debezium, LinkedIn Database, DynamoDB Streams, and Eventuate-Rem. Although this approach is obscure, it works remarkably well. The challenge is that implementing it requires some development effort.